Welcome guys back to Tronics Energy, and for those who don't know what this is a set and reset latch. It's one of the building blocks of building a functional memory used in devices like computers, phones and other gadgets. So we are steps ahead in moving memory. We're building a functional memory and the ALU together. So for this session we are going to do a set and reset latch, this one right here, and it contains only two NOR gates, two input sections. I'm using two NOR gates, but for me I'm using two integrated circuits to make the NOR gates. I'm using OR gate and the NOT gate. When you negate or when you invert the output of an OR gate, you get a NOR gate. So for those who don't have an OR gate, you can just do that a simple trick and to get the NOR gate. So my input section is right here, and both inputs are off, 1 and 2. Set and reset are off. 1 is set and 2 is reset. When both set and reset are off, you see this green LED on, meaning that the circuit is under its normal state, meaning that there's nothing fed, there's no data being fed to the circuit. Once I feed data, which is set, I turn this on, then it immediately switches to red, meaning that we have fed data to the circuit. And if I turn off this red, nothing happens. If I turn it on, nothing happens, meaning that our circuit stores that data, and for later, maybe you're going to use it for later, and we're going to see how we're going to be improving these circuits later on. So once it's set, the only thing that can be done to the circuit to bring it back to its initial state is to press the reset switch, and once you press it, it turns back the green LED, meaning that it has turned back to its normal state. If I turn this off, there's a reset, nothing happens, and until you turn on the set again for you to continue putting on your data. So that's basically what we are going to do today. Please enjoy the show, and yes. So guys, for our set and reset connection, will require two NOR gates. So there we have them, and maybe just to label them, first maybe you can call it NOR gate 1, and this one right here we can call it NOR gate 2. And they require switches. We're going to put maybe two switches, and our first switch we are going to call it the set switch. Our second switch we are going to call it the reset switch. And we are going to interconnect them. So this first switch we connect it to the second NOR gate, this switch connected to the first NOR gate. Then the interconnections now of the output of the first NOR gate connected to the other input of the second NOR gate. Maybe just let me extend this a little bit, yes, to give it room. Yes. Then the output of this second NOR gate we can connect it to the other input of the first NOR gate. Then once we are done with that, we can now go on to place the LEDs, which are going to show us the outputs. We can take the output of the first NOR gate. Okay, let me take it to green. Then the other LED, we can take blue or maybe red. Let me take red. Yes, like that. Yes, so that's basically how the interconnection of a set reset latch looks like. And we are going to power this thing. Okay, we're going to switch on this thing, and we're going to understand how it operates. For those who are new to logic gates, for a NOR gate, the operation of a NOR gate works in a way that when both inputs of the NOR gates are off, it's going to give you a 1 input. And when either of the inputs are 1 or both of them are 1, it's going to give you a off or a 0 output. So only when both inputs are off, it's when it's going to give you a 1 output. And that's what's happening to our first NOR gate, because the set is off and the other input from the output of the second NOR gate is off. That's why the first NOR gate is giving a 1 output. And that 1 output is also interconnected to the input of the second NOR gate, meaning that it's going to turn it off because if any of the inputs is 1, it's going to give you a off or a 0 output. So that's what is happening. So if I press the set switch, we expect that it's going to turn off, it's going to turn on the red LED. We can take the green LED to be a state where the circuit is in a normal condition, and the red LED will show when the circuit is being feed data, when you're feeding data to the circuit. So, and when you want it to be stored. So if I press the set, the red LED is on, and NOR gate 1 is turned off. Immediately it's turned off, it allows or it enables the second NOR gate to be on, and that on output turns on the other input of the first NOR gate, meaning that the first NOR gate is going to remain off until you press this reset switch. So nothing happens. If I close or open the switch again, nothing happens until the reset switch is pressed. Only then it's going to enable the first NOR gate to be on. So if I press the reset, it turns on the green LED again. It turns off the output of the second NOR gate, meaning that it enables the first NOR gate to be on, and the output green will be on, meaning that we have returned the circuit to its normal condition. If I press the reset again, nothing happens until I press the set again to enable the second NOR gate to be on. So I go to the set, press it on, goes to red. Nothing happens if I switch on and off. Then I go to reset, press on, goes back to green. Nothing happens if I press the switch again. Only going to be red again if we turn on the set switch. And that's basically our set reset latch works. So let's build this on a breadboard, and we are going to understand it better. So guys, this is our circuit, the set and reset latch, and the connection are pretty the same as I've done in that simulation that you have seen there. So I'm using a deep switch, 2 inputs, pin 1 and 2. So 1 will be set and 2 will be reset. Then 3 and 4 I'm not using. So the LEDs here are just to show you which input I'm putting on. So the first integrated circuit here is an OR gate. It's an OR gate, and the next one here is a NOT gate. Since I don't have a NOR gate, I'm making them directly. So when you invert or when you negate the output of a NOR gate, you get a NOR gate. So the output of an OR gate, output of an OR gate, if you take it to a NOT gate, it becomes an OR gate. So you can do that if you don't have a NOR gate, or if you have a NOR gate, well and good. That's much easier. So the circuit is, I'm powering it using a 5-volt power supply. These are the outputs. So just like the simulation, my output set is going to be red, and my output reset is going to be green. So green will be showing you the normal state of the circuit, and red will be showing you when the circuit is being fed data. So let's power our circuit and let's check how it functions. So let me take the negative, neutral, place it there. So immediately the green LED is on, because both inputs are off. The green LED is on, showing you that the circuit is under the normal state, and the set and reset are off. So when I press the set, I expect that the red LED should be on and will be turn off the green LED. So we put on the set. Once I turn on the set, the green LED is off and the red LED is on, meaning that we have set a value, or we have set data to our circuit. And if I turn off the set, nothing happens. If I turn off the set, nothing happens to the circuit until I press the reset, or until I turn on the reset. Only that is going to enable the other NOR gate to be on. So if I press the reset, then it turns on the green, it turns back the green LED, showing you that the circuit is back to normal. If I turn off the green LED, or turn off the reset switch, nothing happens to the circuit until you turn on the red, the set switch, in order to enable the second NOR gate to be on. So turn on in order to allow data to be set to your circuit. So that's basically how a set and a reset latch works, and you can build this. So if you have an OR gate, it's much easier, but I don't have it, so I'm making them using an OR gate and a NOT gate. And yes, so you can power your circuit any from 3 volts to 9 volts, but please make sure you check the specification of the characteristics of the maximum values of the integrated circuits to avoid damaging them. So thank you very much guys for watching. Please subscribe to Tronics Energy. So next time we are going to try out a D-latch circuit, and from there we are going on to make a functional memory, and yes, we'll move on from there. So till we meet next time, goodbye guys.